A light year actually refers to the distance that light travels in a straight line through the vacuum of space over the course of 1 year. That's about 9.46 trillion kilometers, equivalent to circling the Earth more than 200 million times. So how long would it take humans to cover 1 light year? Here's the speed of human running. If you ran continuously at 10 kilometers per hour, it would take you an entire year to finish 1 light year. Here's a commercial airplane. Our go-to choice for long-distance travel. Flying at 900 kilometers per hour. It would take 1.2 million years to complete 1 light year. Here's the Concorde, once the fastest passenger jet in the world. It could fly at Mach 2, about 450 kilometers per hour. But even so, flying 1 light year would still take 440,000 years. Here's Voyager 1, currently the farthest human-made probe from Earth. At its speed of over 6,000 kilometers per hour, it would take about 17,000 years to travel a single light year. Now imagine a spacecraft traveling at 1% of the speed of light. Even at that incredible speed, it would still take 100 years to cross 1 light year. Unimaginable, isn't it? But is 1 light year really that far, compared with the observable universe, which spans 93 billion light years across? A single light year seems insignificant. Yet don't underestimate just this 1 light year. Our solar system is surrounded by the Oort cloud, a spherical shell of icy bodies with a radius of about 1 light year. Only by crossing this 1 light year-wide region can we truly say we've left the solar system, and even Voyager 1, moving at more than 60,000 kilometers per hour, would need over 17,000 years to travel through this distance. So, can humans ever leave the Milky Way? How long would it take with today's technology? We know that the Milky Way is about 100,000 light years in diameter, and Earth is about 24,000 light years away from the edge. That equals 227, followed by 15 zeros in kilometers. Only by crossing this distance could we claim to have left the Milky Way. If we tried flying out of the galaxy, in a passenger plane traveling at 900 kilometers per hour, it would take nearly 30 billion years, longer than the age of the universe itself. But what if we switched to the Parker Solar Probe, the fastest human-made spacecraft to date? It can reach an astonishing speed of 5,800 kilometers per hour, about 9 times faster than Voyager 1. At that speed, a trip to Mars could take as little as 4 days, so at least traveling within the solar system seems possible. However, even at this record-breaking speed, escaping the Milky Way would still take 44 million years, clearly unrealistic, according to current theories. Objects with mass can never reach the speed of light. But even if humans someday build a spacecraft that can travel at light speed itself, it would still take 24,000 years just to leave the Milky Way. Considering that human civilization is only a few thousand years old, it becomes clear, unless we master technologies such as wormholes or faster-than-light travel, humanity may remain forever trapped on this cosmic island we call the Milky Way. And living within the galaxy, we may never see its full shape. Unlike other galaxies that can be easily photographed by telescopes, our images of the Milky Way are either stitched together from multiple photos or reconstructed through observation and simulation. In the vast universe, our massive Milky Way, so immense that we cannot even cross it, is nothing more than a faint speck of light. When viewed from billions of light years away, it's not hard to imagine just how small humanity really is in the face of the boundless universe. So why is the universe always black? Why can't the light of billions of dazzling stars illuminate the entire cosmos? This seemingly simple question touches upon one of the ultimate secrets of the universe. As early as the 19th century, German astronomer Heinrich Olbers raised the famous Olbers paradox. It states that if the universe were infinite, static, and uniform, then no matter where we looked in the sky, our line of sight would eventually land on a star. In that case, the night sky should be as bright as the daytime sky. But why is the night sky still pitch black? The first reason is that the universe is only 13.8 billion years old. This means that light from beyond 13.8 billion light years hasn't had time to reach Earth yet. In other words, we haven't received light from beyond the observable universe. in the early 20th century. Astronomer Edwin Hubble also discovered the redshift of galaxies. He observed that distant galaxies are moving away from us, and the farther they are, the faster they recede. This shows that the universe is not static, but expanding, like a balloon being inflated. Because of this expansion, even light that does reach us from within the observable universe is stretched by redshift, transforming visible light into infrared that our eyes cannot detect. This is one reason why the universe appears dark. Furthermore, not all starlight can reach Earth. According to Einstein's theory of relativity, no object with mass can move faster than light. But space itself can expand faster than light. As a result, regions of space far enough away are receding from us at superluminal speeds, meaning their starlight will never reach Earth. Therefore, due to the finite age of the universe and the accelerating expansion of space, the universe we see will always remain dark.